Imagine an invisible, colossal knife carving canyons through our atmosphere, constantly reshaping weather. This atmospheric blade dictates where storms form, how rain falls, and even the air you breathe. Without its relentless, unseen force, our planet's climate would transform into an unrecognizable, static expanse. Understanding this powerful, silent mechanism unlocks the secrets behind Earth's most dramatic weather events. This weather knife is not a single entity, but rather a dynamic interplay of atmospheric pressures and temperatures. It represents the sharp boundaries where distinct air masses collide, creating zones of intense atmospheric activity. Think of a cold front, a dense wedge of chilly air, relentlessly pushing warm, moist air upwards with incredible force. This forceful upward motion acts like a cutting edge, lifting moisture skyward to form towering storm clouds quickly. These atmospheric divisions are crucial because they concentrate energy, triggering everything from gentle breezes to severe storms. Without these distinct boundaries, weather would be far more uniform, lacking the dramatic shifts we frequently observe. Such sharp atmospheric transitions are responsible for the sudden temperature drops experienced during a frontal passage, unexpected influencing sunshine. Recognizing these invisible divisions helps meteorologists predict significant changes in wind direction and precipitation patterns. Ultimately, this constant atmospheric carving defines regional climates, influencing agriculture, ecosystems, and human daily life. Its pervasive influence makes it one of the most fundamental, yet often overlooked, drivers of global weather phenomena. At its core, the weather knife operates through vast differences in air density, driven by temperature variations across Earth. Cold air is significantly denser and heavier than warm air, causing it to sink and spread outwards along the surface. When this dense, cold air encounters a warmer, lighter air mass, it doesn't just mix passively, it aggressively undercuts. This undercutting action creates a distinct, sloping boundary, much like a physical blade pushing beneath a softer material. The warm air, being lighter, has nowhere to go but up, forced rapidly aloft along the cold front's advancing edge. This forced ascent cools the warm, moist air, causing its invisible water vapor to condense into visible cloud droplets. As more moisture condenses, clouds grow taller and denser, evolving into powerful cumulonimbus clouds, the genesis of thunderstorms. But that's not the only way this atmospheric knife operates, shaping our skies with other subtle, yet potent forces. Consider the jet stream, a ribbon of extremely fast-moving air high in the atmosphere, separating colder polar air from warmer tropical air. The sharp boundary along the jet stream's edge acts like a horizontal knife, defining major storm tracks and weather systems. Disturbances along this powerful, high-altitude current create ripples, which then propagate downwards, influencing surface weather dramatically. These atmospheric waves can intensify into powerful low-pressure systems, drawing in moisture and fuel for widespread precipitation. And then something unexpected happens. These waves can become so pronounced they detach, forming isolated pockets of extreme weather. Another example is wind shear, where wind speed or direction changes significantly over a short distance, vertically or horizontally. This shear effectively cuts and distorts existing atmospheric structures, twisting clouds and influencing storm rotation. Vertical wind shear, for instance, is absolutely critical for the formation and organization of long-lived supercell thunderstorms.
It creates a rotating updraft, known as a mesocyclone, which can then spawn devastating tornadoes that touch down below.
Without this specific cutting action, these violent, rotating storms would simply dissipate quickly, lacking their destructive potential. The ocean also feels this atmospheric knife, with strong winds creating sharp boundaries between calm and turbulent water. Even localized phenomena, like sea breezes, demonstrate this principle. Cooler ocean air pushes inland, undercutting warmer land air. These micro-scale knives define daily weather in coastal regions, bringing welcome relief from intense summer heat. This constant, invisible carving ensures our atmosphere remains a dynamic, ever-changing system, never truly settling into stillness. Understanding these intricate cutting mechanisms helps scientists refine climate models and improve long-range weather forecasting capabilities. The interplay of these forces constantly sculpts our planet's meteorological landscape, from deserts to lush rainforests. What truly fascinates is the sheer scale of these invisible forces, shaping entire continents with their persistent, silent work. The atmospheric knife is always at work, even when you cannot see its profound, transformative impact directly overhead. This relentless atmospheric carving directly influences everything from regional drought cycles to abundant agricultural growing seasons. Sharp temperature gradients, maintained by these knives, dictate where polar ice caps persist and where temperate zones thrive. Ecosystems adapt profoundly to these consistent weather patterns, shaping plant life and animal migrations across the globe. For humans, understanding these cutting forces is crucial for disaster preparedness, protecting lives and minimizing infrastructure damage. Farmers rely heavily on accurate predictions of frontal passages and storm tracks to optimize planting and harvesting schedules. Aviation and maritime industries constantly monitor these atmospheric boundaries to ensure safe passage and efficient travel routes. Even daily commutes are affected. Sudden cold fronts can bring unexpected snow or heavy rainfall, altering travel plans. The weather knife also influences air quality, trapping pollutants beneath inversions or dispersing them with strong frontal winds. Its grand-scale operations carve out distinct climate zones, from the arid Sahara to the perpetually damp Amazon rainforest. Over geological timescales, these relentless atmospheric forces contribute to erosion, sculpting mountains and shaping river valleys. The constant redistribution of heat and moisture, orchestrated by these atmospheric blades, maintains Earth's delicate energy balance. Without this intricate, constant atmospheric motion, our planet would experience far more extreme temperature variations globally. The weather knife represents the very essence of Earth's dynamic climate system, perpetually in motion, perpetually transforming. Its unseen influence underscores the profound interconnectedness of all atmospheric processes shaping our dynamic world. The invisible weather knife of atmospheric forces constantly sculpts our environment, driving the diverse, powerful phenomena we observe. From gentle breezes to destructive tornadoes, these sharp boundaries define our climate and shape daily life on Earth. Recognizing this powerful, unseen carving helps us appreciate the intricate dance of energy within our planet's complex atmosphere. If you found this fascinating, subscribe for more incredible insights into the natural world's hidden mechanisms. And let me know in the comments what aspect of Earth's weather patterns you find most compelling.